Hi everyone, today we're going to be looking at arc length and sector area, but before we get there we need to talk about two important formulas, both of which are on your reference sheet, one of them for circumference and one of them for area. Circumference is the distance around a circle. It's kind of like the perimeter, except it's got a really special name for circles, and it's the distance around the center, or around the circle. Two different formulas are given to you on your reference sheet. One is where we have c equals 2 pi r, and the other one where we have c equals pi d. They are the same exact formula except one has a 2r and the other one has a d. C stands for circumference, of course. R stands for radius. And d stands for diameter. The reason you have two different formulas is because radius and diameter are related. D equals 2r. So we can replace the pi d with a 2 pi r because d is 2r. Again, circumference goes around the outside of a circle. So here's my beautiful, terrible circle. And if we're talking about circumference, we're going around the outside. The next thing we need to talk about is something called area. Area is the space inside a shape. And our formula for the area of a circle is A equals pi r squared, where A is area and r again is radius. So if we have a circle and we're talking about the area, that's the space inside the circle. Circumference and area are related to the next two major bullets on your packet. The next thing is called arc length. Arc length is the length of a portion of an arc around a circle. So here, if we talk about the circumference goes around the outside, arc length is a portion of the circumference essentially. So like this piece of the arc, we could talk about its length in terms of inches, centimeters, or anything like that. We will be using a proportion that relates an angle out of 360 equal to the arc length out of the circumference. The angle always is the central angle. So the angle right there located at the center of the circle. Angles can be out of 360 degrees for a circle, which is why we put it over 360. And then the arc length is related to the circumference. Arc length is part of the whole circumference. Sometimes, actually a lot of times, you need to find the circumference first before we can find the arc length. And that's just simply plugging into one of those two formulas, c equals 2 pi r or c equals pi d. The next thing we're going to talk about is something called sector area. This is a portion of a circle inside, meaning an area of a part of a circle. So sometimes you have to find the area of the full circle first before we use a very similar proportion to find the area of a portion, the area of a sector. The angle is still, again, the central angle, always measured out of 360 degrees, and it's equal to area of a sector over area of the full circle. And again, we can find the area of a sector once we find the area of the full circle first. Area of a full circle, don't forget, A equals pi r squared. You'll notice me doing these fancy A's. I use those when I talk about area versus just a regular A because sometimes we call a point by a regular A, so I don't like to get them confused. Fancy A is up to you, it's your call. You can use a regular A if you want. Then we have this nice breakdown here where it says, do I need to first find circumference or area? I kind of have a little trick for you. If you're asked to calculate area of a sector, then you need to calculate area of the circle. Area matches with area. If you need arc length, then you need to find the circumference. I don't really have a trick there, but if you think that area matches with area, then you'll know that circumference must therefore go with arc length. And again, the formula is almost identical. Angle over 360, but on the right hand side is where it changes. X is representing either arc length or area of a sector over what it's calculated out of, circumference or area of the circle. If you flip it, we'll start with some basic questions and then some Common Core questions. So this first one says, determine the area of the sector. Remember, we're going to start writing down these formulas over and over until we get it stuck in our head. The proportion is what I'm talking about. Angle out of 360 equals area of the sector over area of the circle. You can see that I used a little subscript S and a little subscript C. S stands for sector, C stands for circle. So if we need area of a sector, that means first we need to calculate area of the circle, which is a formula that's given to you on your reference sheet, pi r squared. So the radius here you can see is given as 9, so we have pi times 9 squared, and we're leaving our answers in terms of pi. You can see that here. Even if it says to round, we're going to round at the very, very end, so leave everything in terms of pi until the very last step if you need to round. So we have area of a circle is 81 pi. So all I did there was type the 9 squared in my calculator or in my head. It gave me 81, and then I attached a pi to it. Second step is to use the proportion. The central angle they gave us for this sector is 120 out of a possible 360, and it's equal to area of a sector over area of our circle, 81 pi. Now if you would prefer to use an x here instead of that a sub s, area of a sector, that's fine. Replace it with an x and follow through just the same way that you'll see me doing. If you're okay with the letter a with the s, then leave it. So we have 360 times area of a sector, which is equal to 120 times 81 pi. So in your calculator, I want you to type in 120 times 81. Should give you 960, and remember that we need to attach a pi to it. The next thing we need to do is get this a, or your x, whatever you're choosing to use, by itself. So that means we need to divide by 360. In your calculator, type in 960 divided by 360. Again, leaving the pi out of the calculator. Your calculator should reduce it to 8/3, and I want you to keep it as a reduced fraction, and then just attach your pi. Area of that sector came out to be 8/3 pi. In question 2, it says determine the arc length and leave your answer in terms of pi. So we're looking for this arc length out here, which we often call as L, arc length, L length, and it says leave our answer in terms of pi, but remember we need a proportion here. Angle over 360, that's pretty standard, equals arc length. Now we have to decide, do we need area of a circle or circumference? Because I did not see the word area anywhere up here in the question, I'm not going to find the area of the circle, but instead the circumference. So circumference needs to come first, 2 pi r. Plugging in the radius of 12 gives us a circumference in terms of pi as 24. 2 times 12 gives us 24, attach the pi. Step 2 is to plug into the proportion. So I'm going to have you plug in while I do it silently up here on the video. You can look at it, of course, when you're done, so you can check to see if you got the correct plug-in. If you don't like using L for arc length, you may replace it with an X. It makes no difference, you're still solving for the same missing piece. So from here we're going to cross multiply. So we have 360 times L equals, in the calculator, 90 times 24. And don't forget to attach your pi. Our goal is to get L by itself, so divide by 360 on both sides. You should find that L equals 6 pi. The next question says a circle has a radius of 3 feet and an arc whose length is 2 feet. Let's try to sketch a picture for this. we have a circle, a radius of 3 feet, and some arc that it opens up to has a length of 2 feet. It says, what is the measure of the central angle, so we'll choose to call that x, that intercepts the arc to the nearest tenth of a degree. So we'll leave everything in terms of pi until the very, very end. Remember, if we're given arc length, then we have a proportion formula. Angle over, you try to fill it in right now. So you should have had angle over 360 equals L over C. So here we are plugging in. We don't know the angle, so that'll be replaced by an x. We know the arc length is 2, but wait a second, we don't know the c. So that's something that we need to calculate first. Circumference equals 2 pi r. Go ahead and find this answer in terms of pi, just like we've been doing. So I found circumference to be 6 pi, and then from here we're going to plug into our proportion. X over 360 equals 2 over 6 pi, because the arc length was 2 feet over the circumference was 6 pi feet. From here we cross multiply, so we have 6 pi times x equals 720. The next step is to get x by itself, and there's a 6 pi attached by multiplication, so we must undo it by division. But when you divide by pi, make sure you put it in parentheses. Otherwise, your calculator will end up multiplying by pi instead of dividing by pi. So now, at this point, we're going to type the entire thing in the calculator, including the pi, because we're at the very last step, so now we can start thinking about rounding to the nearest tenth. So you're typing in 720 divided by, parentheses, 6 pi, close your parentheses, and hit enter. I found 38.1972, and looking at the tenths place to the right, we look at the 9 tells the 1 to bump up. So x equals 38.2, and we're talking about degrees because this is an angle. The last basic question we're going to talk about tells us that we have a central angle of 280 degrees that intercepts an arc whose length is 14 pi meters. What is the circumference of the circle to the nearest tenth? So we're going to sketch a picture again. This time we have a central angle that's 280 degrees. That's this big angle over here. You can see me outlining it here in red. 280. And it intercepts an arc, the gigantic one, with a measure of 14 pi. It says, what is the circumference of the circle to the nearest tenth? So if you think about our formula, this is arc length, so we're not talking about area at all. Angle out of 360 equals arc length over circumference. We know the angle is 280 out of a possible 360. We know the arc length is 14 pi, but we don't know the circumference. We can just leave it as c, because it says find the circumference. From here, we'll just cross multiply. I'm going to solve it independently all the way through. You do need to round to the nearest tenth. When you're done, check my answer. If you need more time, just simply pause the video. If you need more time, just pause the video, but I did find my circumference to be 56.5. If you flip it over, we'll take a look at some Common Core questions. Again, if you need more time, just pause it, rewind if you need to, so that you can see me watch watch me walking you through the work. Don't walk me, please. Okay, flip it over. The next 3 questions that you see here have been on the Common Core exam. They are all related to area of a sector. None of the Common Core questions thus far have been on arc length, and you saw that we spent a little bit of time on arc length in the basic practice problems, but now we're going to spend more time on sector area in these practice problems together. It says in the diagram below of circle O, the area of the shaded sector AOC is 12 pi. Now your copy might be a little bit dark, but if you can, try to label the shaded part as 12 pi. And maybe we'll just write ourselves a note, area of the sector equals 12 pi. And the length of OA is 6 inches. Determine and state the measure of angle AOC. So if you can, label that as X on your picture. Again, I know it's kind of dark, but do your best to get the X labeled on your picture. They give us the area of a sector. So if you think about the proportion that we were using on the previous page, we have angle out of 360, and we're talking about area of a sector. So A sub S over A sub C. Area matches with area, remember. If we want to find this angle, then we have to have area of a sector and area of a circle. Right now we have area of a sector, but we need the area of the circle. So first we're going to calculate that. Area of the circle equals pi r squared. Remember that can be found on your reference sheet. So we're going to start plugging in. The radius they told us was 6. Leave everything in terms of pi until the very end, don't forget. So once we have the area of the circle, then we can plug into our big formula. X over 360 equals 12 pi over 36 pi. From here we can cross multiply, but before we do that, take a second to look at this. We have a 12 pi divided by a 36 pi. Remember, if you take anything and divide it by itself, those cancel. So now we have 12 over 36, which makes it a little bit easier to cross multiply. So we have 36x equals 12 times 360. In the calculator, it tells us we have 4320. Now, if you had forgotten that pi's cancel, you would have 36 pi x equals 4320 pi. If you see anything on both sides of the equal sign, they cancel. They're gone. Because you would technically be dividing by pi on both sides, dividing by itself again cancels. So whether you do it here in the first step or here after you cross multiply, it doesn't matter. You'll get the same answer either way. So now we're dividing by 36, and we are left with x equals 120. And this is representing an angle, so I've got a little degree symbol there. The measure of angle AOC equals 120. Number 6, again, Common Core question, tells us that the length of the radius of OH is 6 and FH is congruent to OG. So take a look at that for a second. It doesn't tell us anything more about this picture except that we're going to try to find the area of a sector formed by FOH in just a minute. But we have a radius of 6 right here. And if you notice, OG and OF are also radii, so these are also 6. But OG has a hash mark, and so does FH, meaning they're congruent. So FH is also 6. So now we have this triangle with 6, 6, and 6, meaning all of them should have single hash marks because they're all congruent. That means that triangle FOH is equilateral. And so every angle is 60 degrees. Now, because we're trying to find the area of the sector, FOH, this piece, we need the central angle that we had been talking about a while back on the previous page, this central angle. And that's the same as this one, which we said all of them are now 60. So if you can get that labeled on your paper, it'll be helpful for us. So I'll just say central angle equals 60. Now maybe you're wondering how I got 60 in the first place, way up here in the blue ink. Angles in a triangle sum to 180, and there are 3 congruent angles. So if I divide 180 by 3, that gives me 60. Okay, so step 2, if we want to know the area of a sector, we must find the area of a circle. So now we're going to start plugging in to pi r squared. Go ahead and find this in terms of pi, please. So I found 36 pi. And now we're going to use the same exact formula that we used up above, where we have angle over 360 equals area of a sector over area of a circle. So we have 60 over 360 equals area of the sector over 36 pi, the area of our circle. From here we just cross multiply. Again, if you like using x instead of that a with the little s, then that's fine, just replace it with an x. And now we're doing 60 times 36 in the calculator to give us 2160. Don't forget to attach the pi on the very end. Getting a by itself, we have to divide by 360. And you'll notice that all of the choices are in pi, or in terms of pi, so we should leave ours in terms of pi. So in the calculator, you're going to type in 2160 divided by 360. And I ended up with 6 pi, so that gives us choice 3. So the important thing to understand here is that they did not give you all of the information that you would have needed in order to find the area of the sector, unless you memorize some properties and recognize some things that they are giving you. They told us that FH was congruent to OG. OG was a radius, so is OH and FO, meaning all sides of this triangle are all the same and all the length of 6. Now the 6 does not matter much until we get to the area of the circle part, but the fact that all of them have the same congruent sides gives us an equilateral triangle. The equilateral triangle helped us find that every angle in that triangle, including our central angle, was 60 degrees. From there, we followed through the process like normal. So even though it was multiple choice question, we had to do quite a bit of work, you can see that here, in order to get our response. And the next question, the last one before you guys get to practice on your own, says that we have circle O in the diagram below, and the area of the shaded sector, LOM, is 2 pi. Again, if you can try to get this written in there, that would be helpful. The length of NL is 6 centimeters. What is the measure of angle N? So I'm going to just kind of put a double arc mark there. That's what we need eventually. They tell us the area of the sector is 2 pi. They give us NL, which is representing the diameter. So if we cut that in half, that gives us each a radius of 3. So R equals 3. Now if you think about our proportion when we have area of sectors, we have angle over 360 equals area of the sector over area of the circle. The angle that we've always talked about is the central angle, the one located at the center. So if we use this proportion, we're going to get an angle other than what we wanted. However, if we can find this central angle, and you think back to what we did in the last video, we can find the central angle's arc, ML. If we find arc ML, then we can bring it back inside to find the measure of angle N. So first step is to use this proportion. We have the A sub S, the area of the sector, was 2 pi. We have the angle, no we don't, just kidding. We need the angle, but we don't have area of the circle yet, so we need to find that. First, area of the circle. Please find this in terms of pi. So I find the area of the circle to be 9 pi. Now we're going to plug in so that we can find the angle. X over 360 equals 2 pi over 9 pi. Remember, pi's cancel if they're beneath each other. So now we have cross multiplying to give us 9x equals 720. Divided by 9 gives us x equals 80. Now remember that even though there's a choice that says 80, this may not be our answer because what we just found was the central angle. So we know that a central angle of 80 degrees opens up to arc ML, and central angles are equal to their arc. So the measure of arc ML is also 80 degrees. And if you just want to write central angle equals arc, that might be a hint for you when you go back and try some problems on your own. So that means this arc out here is 80. In order to go inside to an inscribed angle, step 3, the measure of angle N is 80 divided by 2, arc over 2 for inscribed angles. I'm going to sketch that or write that off to the side. Inscribed angle equals arc over 2. Again, to go inside, we divide 80 by 2 to give us a total value of 40 degrees. Choice 3. If you need to go back and rewind to revisit any part of this movie or this video, feel free to. Otherwise, ask teachers questions that are near you. Get started on the practice independently before you take your assessment. Good luck.